electricity powers everything, from your phone to massive factors. But without transformers, all that power will be impossible to deliver safely or efficiently. Today, we are uncovering the security rule of electrical grid, step up and step down transformers, the silent champions keeping our world switched on. Okay, now, what is transformer? Let's discuss about transformer. What are they? At their core, transformers are simple but genius devices. They use electromagnetic induction to transfer energy between the circuits. No moving part, no sparks. Inside of the transformer, we have two coils of wire. The two coils of wire, the primary and secondary, no moving part, no sparks. So here, an AC flows through the primary coil. If we apply AC current to the primary coil, it creates changing in magnetic field. That induces voltage in the secondary coil. And boom, energy flows, transmit to the right voltage level. So this is about transformer. Let's dive into high transformers only work with alternating current, but not with direct current, because AC voltage constantly change direct and creates that change in magnetic field. But by applying direct current, we cannot get changing in magnetic field. So transformer to work, it needs change in magnetic, needed to induce voltage in the secondary coil. So this is done by applying alternating current only. So by applying direct current, we cannot create or we cannot get voltage at the output of the transformer. Because of this, transformer only uses alternating current. Now let's discuss about step up and step down transformer. To create or to make a transformer step up or step down, what is the secret? So the secret lays in the number of turns in each coil. So by changing number of coil in the primary and secondary winding, we can create step up or step down transformer. For example, if the secondary coil has more turns than the primary, it is a step up transformer. So we can get voltage at the output of the secondary greater than the primary winding. Okay, if it has fewer turns, it is a step down transformer. This is making by the secondary coil is less than the primary coil. So if it is a step down transformer. This is used for lowering the voltage. That means the output voltage. If the incoming voltage is high, we want to decrease the amount of voltage, we use step down transformer. This is applied by decreasing the numbers of turns in the secondary. So power stay nearly constant, but the voltage and current sweep roles. That means when we step up the transformer, we increase the amount of voltage, but decrease the amount of current. Whereas in step down transformer, we decrease the amount of voltage. Okay, the amount of voltage, and we did like this. That means this is lets us to transmit over long distance efficiently. If we make step up transformer, this is advantage for transmitting the power over long distance efficiently. Whereas we use step down transformer to use safely in the outlet, in the socket. We can use step down transformer to safely use at home. That means it is low voltage and high current. That means as compared to step up transformer. Okay, let's dive into why step up transformer matter for power transmission. So why step up transformer matters for power transmission? The power plant, as we know, electricity starts at low voltage. For example, like 11K to 25K voltage. So if we sending this low voltage through miles of cable and waste tons of energy, that means a number of energy can waste as heat. So to remove this, we use step up transformer, because this cranks the voltage up to hundreds of thousands of watts, sometimes up to 400 volts. So this cuts the current dramatically. That means it decreases the loss in the wire. That is how massive power grid keeping energy flowing efficiently across entire country. So by using step up transformer, we decrease the losses in the transmission line, because in the transmission line it is very long distance. It needs to transmit the electricity without losses, that means, so with high efficiency. So this is done by using step up transformer. Okay, let's dive into very critical point, which is step down transformer. This step down transformer makes electricity safe and usable. Once the electricity reaches your number watt or reaches The demand step-down transformer brings the voltage down to the safe levels. So first, it intermediates voltage around 11K to 33K voltage. First, it step down to 11K to 33 up to 33K voltage. Then finally, it's to the standard value. It step down to the standard value, which is 120 volt or 240 volts, as the country may be different. The standard value of, for example, to use by laptop, by stove, by smartphone, at the last output, safe and usable may be 120 or 240 volts, as regarding to their countries. So without step down transformer, plugging your phone to or to light bulb would be dangerous, even damage. So this step-down transformer is very important to make electricity safe and usable. Okay, let's discuss about full real-world use beyond power lines. So transformer beyond power line. So these transformers are not just for big power grid only. They are inside your phone charger, laptop power supply, and even electric trains. So this step-up transformer power railway lines to run train and smoothly over long distance. Whereas step-down transformers power your gadgets safely, convert wall outlet voltage to what your device needs. So that means power transformers are not just for big power grids. For example, in transmission line, in distribution, only we cannot use transformers. In very small size, in our phone, in laptop power supply, even electric trains, we can use this transformer. So this is about beyond the power lines. Final recap our discussion. To sum up, step up and step down transformers are the backbone of power delivery. They keep energy flowing efficiently and safely from massive power plants to your living room. If you found this insightful, hit the like button, subscribe to FireTech Vision for more sharp electrifying lessons, and ring the bell so you never miss out.